This is the Solutions and Molarity Lab, which accompanies Lesson 26 in your Friendly Chemistry course. In this lesson, you will have been describing to your students the definitions of solute and solvent, and then the concept of molarity. In this lab activity, your students will experience in a hands-on way the preparation of various molar solutions. Materials that you'll need for this lab include powdered drink mix packets. You can either use hot chocolate mix or hot cider or Kool-Aid brand mix packets. You'll need a styrofoam cup and spoon. Then you'll also need a container which measures at least 1 liter. We're just using a canning jar here, which is actually a 1-quart canning jar, but it does have the milliliter increments on the side of the jar, and then some table salt. You'll actually be preparing the drink mix with your students, so you'll need a means of providing hot water for them, or at least access to a microwave where they can warm water for their drink mix. To begin the activity, you'll first tell your students that they will actually be preparing the hot drink for themselves, and that the drink mix powder will actually be the solute portion of their solution. The prepared hot cocoa drink will be their solution, so the powder becomes the solute, and the hot water that you'll provide for them is the solvent. So that's your two definitions of solute and solvent that go to make up a solution. You'll move next to the concept of molarity. To demonstrate the concept of molarity, ask your students to take their cups, and on the side of their cup just to make a mark near the top edge of the cup. Next to that mark, we're going to write that this mark represents 1 liter of volume. Okay. Now, obviously, this amount is not actually 1 liter, and you can refer your students to the 1 liter jar or container that you have to show them an actual liter is quite a bit more. But for this activity, we're going to pretend that at this point on the cup that represents 1 liter. Okay. You can also put on here at the same time that 1 liter equals 1,000 milliliters. It doesn't hurt to go ahead and practice again and again that 1 liter is the same as 1,000 milliliters or 1,000 cc's in the case of liquids. Okay, so then you can set that aside, and next go to your drink mix and tell your students now that we're going to pretend again that the contents of 1 drink mix packet equals 1 mole of the compound of the drink mix powder there. So 1 packet here equals 1 mole, and you can have them write on the outside of their packets that this is 1 mole of the compound there. Now next, take them back to the box that the drink mixes came in, and see if you can find on there what is the mass of 1 of the packets. And if you look down here on this particular box, it says right here that each packet is 20.2 grams. Okay, 20.2 grams in each packet. And so we can then say that 1 mole of the drink mix compound here has a formula weight of the 20.2 grams there. So 1 mole here equals 20.2 grams, and you can write that on there as well. So that's essentially the formula weight. 20.2 grams is a mole. So your molar mass, or your formula weight, is 20.2 grams. Okay, that'll be important a little later on in the lab exercise here. Okay, now next you're going to have your students prepare their drink mix, and so you'll provide the hot water, and so you'll have your students fill their cups approximately up to their mark there. Okay, and then they'll open and pour in their drink mix powder, and go ahead and prepare the powder. Okay, now as they're stirring up their drink mix there, tell them again, they've now taken 1 mole of the solute, mixed it into 1 liter of the solvent, and therefore they will have created a 1 molar solution. Okay, 1 mole in 1 liter represents a 1 molar solution. So, and you'll want to go ahead and write that down for them on your board or flip chart, that 1 mole mixed into 1 liter of solvent there gives them a 1 molar solution. And you might want to note that molarity, or when they indicate molar, it's a capital M. We've been talking about moles all along, which is a measure of mass there, is a lowercase m. So molarity is a capital M. Okay, so 1 mole of the solute mixed into 1 liter of the solvent will give us a 1 molar solution. Now, challenge your students. Ask them, well, how do you think you would make a 2 molar solution? 2 molar solution. Hopefully they'll say, well, we just mix 2 moles of the solute into 1 liter of the solvent. So it would take two drink mix packets, and 3 molar would take 3 drink mix packets to make a 3 molar solution, or a solution of 3 with a molarity of 3. Alright, now make sure your students are aware that this is not the true liter here, and that the situation is all, quote, a pretend situation. Now, as they go ahead and enjoy their drink mixes there that you've made for them, refer them to the salt next. Okay, and the challenge here is for them to prepare for you a 1 molar sodium chloride, which is table salt, a 1 molar sodium chloride solution. Okay, and this time will be a little more accurate in that they can use the actual 1 liter container. Now, if you're using quart jars, on the side of the jar right here is 800 milliliters, and so you can kind of estimate, well, almost to the very top, not quite to the top of the jar, would be the 1000 milliliter mark. And so again, we're just going to have to do the best you can with your equipment. If you do have a beaker or flasks that do measure to exactly the 1000, then you can actually make a more accurate solution. Now, one thing you'll want to note with your students, when we prepared the hot chocolate here, we put the water in first and then add the cocoa mix on top, which was the better way to have a more successful drink. When we were in the end, the powder doesn't stay stuck in the bottom of the container. When a chemist goes to actually prepare molarity solutions of particular molarity, what they'll actually do is they'll go ahead and put that solute in the bottom of the container and then add the water to it. Now, that's not the situation in all cases. Okay, when you're preparing various strengths of acids, you will want some water in the bottom, and then you add a pre-measured amount of your concentrated acid, and then you can bring it up. But in general now, when a chemist goes to prepare a certain molarity of solution, they'll put their solute in first in the bottom, and then bring up the total to the 1,000 milliliter mark, or the 1 liter mark. Okay, so in essence, there's a little bit less water than the 1 liter, because you've got some of the volume taken up by the solute that you've already put in. So challenge them now. How will they make a 1 molar solution of the salt? Now hopefully they'll recall that, well, if we're going to make it 1 molar, we need 1 mole of salt. And then say, well, how do you know what makes up 1 mole of salt? And they'll hopefully say, well, we just need a formula weight for the salt. And they should be able to go about and calculate that formula weight for you, which is a little more than 58 grams. And then if you have a scale present to use, handy to use, have them go out, have them weigh out the 58 grams of the salt, and then they can add the salt to their container, and then using water they can go ahead and fill it up to the 1 liter mark, and then present to you a 1 molar solution of sodium chloride. Alrighty. Now one other thing you might point out to them at this point is that there's another means of indicating concentrations of solutions. It's the same concept here, except there's a different name given to it. Molarity, when you have 1 mole per liter, and we call that a 1 molar solution, it can also be referred to as a 1N solution, where the N stands for normality, or a 1 normal solution is 1 mole of solute in 1 liter total solution there. So molarity and normality mean the same thing. So on some containers that you might buy from a chemical supply company, instead of saying 1M solution, if these are premixed solutions, it may say 1N, and that means the same thing. Normality and molarity, the same definition there. Once your students have prepared the 1 molar or 1 normal solution of the table salt, challenge them, say, well, what if I wanted a 3 molar solution? And they should be able to say, well, we just take the 58 times 3 and weigh out that much salt, and we would mix it with our water, then our solvent there. And ask them, say, I needed a 0.8 molar solution. What if I needed a 0.8 molar solution? They should say, well, we just take the 0.8 times the formula weight, or the 58 grams, and whatever that result is, that's the amount of salt we would get to make that molarity of solution. So this is the Solutions and Molarity Lab, which go with Lesson 26 in your Friendly Chemistry course. Enjoy your time with your students.